Hey guys, so I'm just going to work over a couple of the sample problems that will help you better review for solving and graphing inequalities. So let's jump right in. The first one says solve and graph the following inequalities. So right here we have 3 times the quantity of x plus 7 is less than 2 times the quantity of 2x plus 8. This one you're going to solve and graph on a number line. So the first thing I'm going to do is do the distributive property. So I get 3x plus 21, because that is a positive 3 and that's a positive 7. I'm just going to drop my inequality sign. And here I get 2 times 2x is 4x. 2 times positive 8 is 16. And here you have a choice. You can move all your variables to the left side or all your variables to the right, and then vice versa with the numbers. What I'm going to do is I'm going to move all my variables to the right because I notice I have more x's on the other side. So I'm going to do the additive inverse of positive 3x, which is negative 3x, to both sides. That zeroes out. Drop 21, and I get 21 is less than x plus 16, because 4x take away 3x is just x. Since I move all my x over to one side, now I need to get rid of 16 by doing its additive inverse, which is subtract 16 from both sides. This zeroes out, and I get x. 21 take away 16 is 5. And I drop my inequality sign because I didn't multiply or divide by a negative. So 5 is less than x. You can also do the symmetrical property of equality, which it could become 5. X is greater than 5. And to graph this, since this is just a greater than, there is no closed circle. So draw my number line here, put my boundary, which is 5, open circle, and all the values that are greater than 5 is to the right. So I'm going to draw my arrow this way. And you can quickly check your work. So I'm going to just choose 6 because I noticed that 6 is underneath that arrow. So I can put in 6 for x, and I get 3 times 6 plus 7 is less than 2 times 2 times 6 plus 8. And here I have 3 times 13. 2 times 6 is 12 plus 8. And I get 39 is less than 2 times 20. 39 is definitely less than 40. So that checks out. So I know that my arrow is pointing in the right way. You can also do 5, but 5 wouldn't work because remember that is not a greater than or equal to. It is just a greater than sign. All right, let's move on to the next one. Here I have what's called a compound inequality. This is considered a conjunction. So I have 3 is less than or equal to 2 times x plus 4 minus 3 is less than 15. There is a couple strategies to approach this. The one we talked about in class is working on this simultaneously. You can definitely do that. But a good way to look at this is I'm going to go ahead and just kind of ignore this for right now. And what do you notice? If you take away less than 15, you have just your one normal inequality statement. You can do that, break it up into 2 different chunks, or you can do it all at once. It is going to be up to you. So what I'm going to do first is I'm going to do the distributive property. So I get 3 is less than or equal to 2x plus 8 minus 3 is less than 15. And then I'm going to combine like terms. So I get 3 is less than or equal to 2x plus 5 is less than 15. Subtract 5 from all sides. So that becomes, let me rewrite that. That does not get zeroed out there. That becomes 10. That zeroes out. I drop the 2x and I just drop the symbols. And 3 take away negative 5 is negative 2. Now I'm going to divide every side by 2. and I get negative 1 is less than or equal to x, which is less than 5. Quickly check. I did not divide or multiply by a negative number, so I do not have to flip any of my inequality sign. So here I have a conjunction. Negative 5 is less than or equal to x is less than 5. So to graph this, I'll go negative 1, negative 2, negative 3, negative 4. Mr. Wynn totally messed up there. Not even paying attention. 1, 2, 3, 4, 5, 6. I can start there because we're going in the positive, right? And it is that one says that is negative 1 is less than or equal to. So that is a closed circle. And my other boundary is less than 5, so a closed circle. And we're trying to find all the values of x, which colors here, all the values of x that is greater than negative 1, including negative 1, but less than 5. So that's why this is called a conjunction, because everything in between negative 1 to 5 is part of my solution set. And we can actually check our work. And since 0 is part of my solution set, I'm actually going to go check with 0. So I'm going to rewrite it. 3 is less than or equal to 2 times 0 plus 4 minus 3 is less than 15. So I get 3 is less than or equal to 2 times 4 minus 3 is less than 15. 3 is less than or equal to 8 minus 3 is less than 15. 3 is less than or equal to 5, which is also less than 15. And that is definitely a true statement. 5 is greater than 3, but less than 15. So we have a true statement, which means I have the right solution set highlighted or drawn on the number line. Okay, so that would be a conjunction. All right, let's move into the disjunction because of this word or. So this is a disjunction. So since it's a disjunction, what I would do is I would just approach one at a time. So this is A, this is B. So let's do A first. So A says that it's negative 2, x plus 2 minus 7 is greater than 9. Okay. So since it's a disjunction, I'm not going to be able to do it all at once. So I'm just approach one at a time. So distributive property first, I get negative 2x plus negative 4 minus 7 is less than 9. Combine like terms, I get negative 2x minus 11 is greater than 9. Here I'm going to do the additive inverse of negative 11, which is positive 11 to both sides. And I get negative 2x is greater than 20. Going to divide both sides by negative 2. What do we notice? Well, we're dividing by a negative coefficient. We're dividing by a negative 2. The actual action is negative, so we're going to have to flip our sign. So my first solution is x is less than negative 10. So that's A. Let's go to B. B reads 3 times x plus 3 is greater than negative 6. First thing I'm going to do, distributive property. I get 3x plus 9 is greater than negative 6. Additive inverse here, subtract both sides by 9. I get 3x is greater than negative 15. Because negative 6 with negative 9 is negative 15. Divide both sides by 3 to get x by itself. And since I'm not dividing by a negative, just a positive 3, I do not flip the sign. So here are my two solutions, my two boundaries. What do we notice? We have all of the numbers that is less than negative 10. So I have x, the second one, all the number that is greater than negative 5. So both my solution deals with negative, so I'm just going to throw it in a number line. And since I'm going to go negative 11, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, and negative 3. You can keep going if you want. And I'm just going to graph each one. The first one says x is less than negative 10. and that is a less than sign. Now the less than or equal to, so it's an open circle. Open circle with the negative 10. And then all the numbers that is less than negative 10 is going to be going to the left of that. The second one is all the solutions that is greater than negative 5, but not including negative 5. So those are my two solution set right there. That's my solution set. That means between negative 10 and negative 5, there's no arrows there's no arrows going there because those are not part of my solution set. This is a disjunction, which means they do not share solutions. Okay, I hope that helps. Feel free to take notes, pause the video. Please email me if you need extra help. Thanks, guys.